Good morning and welcome to this new webinar on HEIMDALL project. Thanks to attend for those who are following this webinar online. As you may already know, this webinar will be available on the website of HEIMDALL as a recorded video. As always, there will be a room of 5 minutes for questions and answers at the end of the webinar. Well, the webinar of today is about the methodology of to analyze case studies in HEIMDALL. This is the outline of today's webinar. I will make a short revision of the HEIMDALL general objectives, since you already have the previous webinar where the detailed objectives of the project were presented by the project coordinator. Then we will talk about the use cases in the projects and the methodology to extract information from these case studies and its different steps of data collection and data processing. As a general objectives, HEIMDALL stands for a multi-hazard cooperative management tool for data exchange, response planning, and scenario building. HEIMDALL wants to develop a series of tools for response planning and scenario building for forest fire, floods, and flash floods and landslides. But HEIMDALL goes far beyond than that, and their tools will also be applicable for the rest of the phases of the emergency management, like mitigation, prevention, response, and recovery. HEIMDALL will also integrate those tools in a series of technical tools in a multi-hazard federated platform. And the idea of HEIMDALL is to test the system prototype in a series of demonstrations and in a final operative demonstration with the collaboration of all end users partners in the consortium. All knowledge from the emergency management experiences that HEIMDALL will gather, store, and analyze rises from the end users partners, but also from the information, lessons learned, and best practices identified along their management of emergencies. For the HEIMDALL consortium, the way to gather all this information and the way to gather all this data and knowledge is or will be by collecting a series of case studies of relevant incidents about the three main hazards of the project. As I said, forest fires, floods, flash floods, and landslides, and from the different point of views of the end users partners in the consortium. So that means from the fire and rescue service profile, from the police profile, medical service, command and control, and civil protection. This data and knowledge will be used to prepare the different demonstrations of the project by creating scenarios and a repository of lessons learned and best practices. The case studies, as an example of experiences, will also serve to help technical developers know how the first responders think and act in their emergency response operations, and will help also technical developers to understand the way how first responders take decisions in their emergency incidents and their emergency environments. The added value of this methodology is that can be used not only for HEIMDALL partners or for the HEIMDALL consortium, or let's say for the HEIMDALL project, but also can be used for other first responders who wants to integrate or who wants to use a way to collect and to gather data and knowledge from their incidents. because most of the emergency services produce reports of their services, of their emergencies, of their incidents, but nowadays it doesn't exist a standardized methods in Europe to collect data, information, and experiences from the incidents, from emergency incidents. Each field responders organization or emergency services use different data collection methods and analysis depending on the types of the data available. Depends on their needs, depending on their level of knowledge or their availability of personnel. In general, this situation derives into a lack of robustness and consistency of the data available from field responders, which is normally a problem when you want to develop research projects joining field responders and technical partners. So the objective of this methodology is to design a standardized way to collect information during the post-incident analysis, as much flexible as possible to let the different end users adapt it in their different realities. The methodology used in HEIMDALL is based in the one developed in the frame of the GeoSafe project during Secondie in Corsica, and taking as a use case the forest fire of Olmetri Tuda in 2017. As you can see here, the methodology comprises 5 main steps to collect data and information, from the data collection, the definition, what kind of data, the data processing and validation, the analysis of risk and the behavior, the definition of the strategy followed, the priorities, the tactical objectives, the operations carried out, the impact of the incident, and finally, the collection of the applicable lessons learned. The process of data collection takes place during and after the incident, and this includes firstly information about the incident or the event, often collected by emergency services and the inhabitants of the region. And secondly, also external information from databases. As internal information, we can find mainly cartography, like topography, infrastructures, etc., or even operational cartography, which is internal from field responders. That means critical assets, housing, roads, etc. But also external data, where we can find information about weather data that often is provided from national weather services, but also about information about the statistics of the population, etc. It's also interesting to collect images and video recordings, which are very valuable sources of in-situ information that will be used in the incident analysis phase, which is the second phase of this methodology. It is also important to mention here that there is a lot of information available in the social media, like Twitter, Facebook, etc. Mainly, we are talking about photos, but is extremely needed to validate this kind of information. And this validating is carried out in this next step, in the data processing. The process of data comprises the extraction of the data, ordering that data, and validate it by an expert criteria. That means an expert from the emergency services. As I mentioned, the images about the incident is an important source of information and can be obtained from multimedia sources, internal or even external, like social media. In that case, This is a picture from or a snapshot from a video recording from the service Horus from the cities 2B from Corsica. All the data gathered it must be mentioned here that all data gathered must be validated by an expert from the emergency management service or a group of them or a group of experts before performing the final analysis of that data. For example, the geolocation of the images and videos, the validation of the incident evolution and behavior, the validation of the cartographic information, etc. It is also highly recommended to organize interviews with citizens that were directly affected by the incident. In this sense, this kind of information could be used or can be used to assess the effectiveness of the actions like evacuation or sheltering, and to validate the evolution of the incident. As an example about what kind of information can be extracted from photos, here this is an example of the photos collected as a field observation during the forest fire in Corsica. The photos are sorted by time and located in a space by coordinates. And each photo, it has associated information about fire behavior. In that case, it has information associated about the distance of spotting. Well, in that case, is 0. If it's a photo belonging or showing pictures about the head of the fire, the flank, or the tail, and also the flame length. In that case, it's meters, so 0.5 or 2 meters of flame length, etc. Then this information can be drawn in a map, and in the next steps of the methodology during the analysis can be used to obtain a final reconstruction of the incident and its evolution. The analysis of the risk and behavior depends on the type of the hazard. The data and the variables that brings information changes, of course, from one hazard to another. So it's not the same the data that we need to analyze forest fires that the kind of data that we need to analyze floods or we need to analyze landslides. In this sense, what is valuable for forest fire is to collect information about pre-incident forest fire risk, either annual or seasonal risk, the previous weeks, previous days, etc., like draw code index, fire weather, the evolution of the draw code, the evolution of the fire weather index, etc. Then you can also perform analysis of the evolution of the perimeter, the isochrones, and of course the analysis of the fire behavior that can be obtained, as mentioned, from the information of pictures. In that case, here we obtain it from the analysis of 50 pictures, the map of the isochrone, so the evolution of the fire over time, the map of the flame length and its evolution over time, the map of spotting distance, and the map concerning the speed propagation of the fire. And as I said, all this information was obtained by the analysis and the geolocation of those photos. So this is what matters for fire, but what matters for floods is completely different. What matters for flood is the reconstruction of the incident using models based on real information, and real information about the evolution of water depth and the evolution of the water velocity. It is also important, like in fires, to have an inventory of historic flood events to be used as a base for adjusting the models. also in landslides. In that case, what is relevant for landslides is the collection of information about the terrain characteristics like topographic and geological that can be complemented with information about soil and land use, etc. It is also important to analyze the triggering conditions, mainly weather conditions. Here we are talking mainly about rainfall, so accumulated and intensity of rainfall that can be provided by the national weather services. Like also again, like fires and floods, it's very important to have information about previous events, which is useful to improve and adjust the existing models. Also here, the satellite imagery and sensor radar can be used to obtain the evolution of past events or to monitor current events. So apart from the analysis of risk and behavior, it is crucial to collect information about the decisions and actions from the study cases. So the information about decisions and actions that were taken during the incident management. This information will allow the system developers to understand the incident evolution and its management by knowing the deployment of means over the incident area and over the time, following a general strategy defined by the incident commander to accomplish the common interagency objective. In that case, it is important to mention that each country, region, or emergency services or emergency service has different crisis management organization or structure that influences on the way the decisions are taken during an emergency event. As shown here, most or some of the emergency services in Europe, they base their crisis management organization on the incident command system developed, which is the one shown here, the general structure, the incident command system developed by the US Forest Service in the United States. For impact and operations, but for impact, HEIMDALL, or to analyze the impact, HEIMDALL will use the risk matrix provided by the partner FBBR, which is a diagram composed of 2 dimensions, probability and consequences, which can be used to give an overview of various risk impacts and evolution over time, and evolution depending on the variation of the consequences or the probability of the impacts. Through the diagram, it can be estimated the particular threats that constitutes an acceptable risk for the organization, and whether or not the risk level for a given threat is unacceptable is determined from the probability and the possible consequences that that threat can result in an incident. As a final step of this methodology, for collecting lessons learned in HEIMDALL, we have based our methodology on the one already defined and used by the organization called the Natural Conservancy in the United States, and the guide defined by them called Capturing Lessons Learned. So mainly, as a general idea, documenting lessons learned is of course an opportunity for improvement and an opportunity to helping a team to identify a strength or weaknesses from the consequences of a specific incident through questions like what went well, what didn't go well or had unintended consequences, or questions like if you had it all to do over again, what would you do differently, or what recommendations would you make to others doing similar actions or doing similar projects. The mechanisms or the processes or the methodologies used to collect, share, and disseminate lessons learned may vary, but in general are comprised of 5 main steps, of 5 main elements. So mainly, and first of all, defining a project or defining a case study in the case of HEIMDALL, collecting information or collecting lessons learned and best practices, verifying the applicability of these lessons learned for the organization, and also verifying the applicability, store and manage the lessons learned in a repository, and finally disseminate it through other stakeholders or to other end users. HEIMDALL will take profit of this methodology by managing the lessons learned and also disseminating lessons learned through all end users. Well, that's all from my side in this webinar. I think from HEIMDALL point of view, one of the strongest points is that the system is not only going to provide tools for response planning, but also will serve to help the first responders to classify and store their knowledge, because all of them, they are very expert, or they have very expert people, but what we want is to help them in collecting data and help them in using that data to support the existing experience and not to replying the existing experience. So thanks a lot for attending.